Welcome to section 7.3 of Geometry, Proving Triangles Similar. And here's your math joke for this lesson. What did one right triangle say to another right triangle? Ready? The answer is, let's go square dancing. There's a good chuckle for you. Okay, let's start off this lesson with a quick review. I want to see if you can name the 5 ways in which triangles are congruent. Go ahead and write them somewhere down on your paper. And hopefully they match with what I am writing down on mine. We have side, 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 angle, angle, side, angle, 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 side, and then the last one was HL. We're going to use some of these ways to prove triangles are similar. Okay, the next problem says, what are the criteria, and there's 2 things, for objects to be similar? Number 1, hopefully you remember this, corresponding angles must be congruent. And the second thing, corresponding sides, they are not going to be congruent. They could be, but they don't have to be. They are going to be proportional. Meaning if I compare all corresponding sides, they have the same ratio. Okay, now let's start talking about ways to prove triangles are similar. And the first way is angle-angle similarity. And this kind of looks like one of the ways to prove triangles are congruent, but it's not exactly. But it goes along the same purposes. If you're going to prove 2 triangles are congruent, or 2 triangles are similar, you need 2 corresponding angles to be congruent. So I have 2 triangles here, triangle A, B, C, and D, E, and F. So let's say I have angle A congruent to angle F, because they're corresponding, and B congruent to angle D. Well, right there then, that is enough to say that this triangle, triangle ABC, is similar to triangle FDE. We know that they could be congruent as well, but we know right now that they are similar for sure. Okay, another way to prove triangles are similar is by the side-side-side similarity. Now, this does not mean that the 3 sides are going to be congruent. It means that the 3 sides are going to be proportional. So they should have the same ratio if I compare all 3 corresponding sides. So I'm going to start by labeling my triangle. I have triangle IGH, and its lengths are going to be 3, 4, and 5. And then I have triangle JKL, and its lengths are going to be 6, 8, and 10. Now I need to check that all 3 sides are proportional. So I'm going to start by writing my ratio. I want to compare side IG to side JK and see if they have the same ratio, or if they, and see what their ratio is. So that is going to be 3 to 6. And I can simplify that to 1/2. Now I want to compare GH to KL, and they're corresponding, and that's going to be 4 to 8. And I simplify that, and I have 1/2 as well. And the third ratio would be comparing IH to JL. So that's going to be 5 to 10. And I see here then that all 3 sides have the same ratio. So that tells me that triangle IGH is similar to triangle JKL. And I'm done. The last way to prove triangles are similar is by the side-angle-side similarity. And in order to do this one, I need one corresponding side to be proportional, one pair of angles to be congruent, and then the other side to be proportional as well. So let's start by labeling. I'm going to have A, B, C, and then I'm going to say M, N, and O. All right. The length from A to B is going to be 2 units, and the length from A to C is going to be 3 units. And I want angle A to be congruent to angle M. The length from M to N, I'm going to make it 6, and the length from M to O, I'm just going to make it as 9. Alright, notice that we have 2 sides labeled, and then the angle in between them, because the corresponding angle must come exactly in between those 2 sides. Kind of how it did for side angle side congruence statement. Alright, now let's check to see if our sides are going to be proportional to each other. So I want to compare AB to MN. So that's 2 to 6. And we can simplify that. Both of those numbers are divisible by 2. And I get 1/3. I know that angle A is congruent to angle M. So there's my angle in between. And then I want to compare my last sides, AC to MO. And the length from A to C is 3. The length from M to O is 9. And when I reduce that one, 3 and 9 are both divisible by 3, and I end up with 1/3 again. Notice I started with the first triangle, or this triangle on top, both times I wrote my ratio. You have to start from the same object both times. So, that tells me that triangle ABC is similar to triangle MNO. I hope you enjoyed that lesson. We're done for today. So remember the ways to prove triangles are similar. We have angle, angle, side, 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 and side, angle, side.